Hello students, welcome to Learner's Planet, our problem solving session of periodic classification of elements. So till now we have discussed questions related to the properties of elements, that is along the period as well as the group. In this session we will be solving few questions in which you are asked to arrange the elements according to their increasing sizes or their reactivities or their valencies, which is normally the pattern of question which comes from this topic. So let's start our problem solving session here. Here our first question given is, which of the following statements is correct? Now our first statement here is, electropositive nature of elements increases from left to right in a period in the periodic table. Is it? Say if I am taking up the elements, what is electropositive character? I told you in the previous session that electropositive character is the tendency of an atom to lose electron. Right? So this is your electropositive character, that is a tendency of an atom to lose electron. Now what happens to it? If we move from left to right in the period, I have explained you this in detail in the previous session. Now when you move from left to right, what happens to electropositivity? Electropositivity decreases. Now if I move from top to bottom in a group, so what happens? Top to bottom in a group. Now what happens? The electropositivity increases. Now what is your thing? Electropositive nature of elements increases from left to right in a period in the periodic table. Is it? No. It decreases. So this one is wrong. Let's take up the next point here, that is electropositive nature of elements decreases from left to right in a period in the periodic table. Is it? So what it is doing? It is decreasing. So this is right. What is the next option given here? Electropositive nature of elements remains more or less constant in a period in the periodic table. Is it? Does it remain constant? No. So this option is also wrong. Now the next option here is, electropositive nature of elements first increases, followed by the decrease from left to right in a period in the periodic table. Is it? No. It decreases only. So this is also wrong. So what is the correct option? That the electropositive nature of elements decreases from left to right in a period in the periodic table. Let's take up our next question here. It is, arrange the following elements in the order of their decreasing sizes. Now what you have to do? You have to arrange potassium, magnesium, phosphorus, oxygen and fluorine in the order of their decreasing sizes. Now what happens to the atomic size when we move from left to right in a period? Say I am moving from left to right. What will happen to the atomic size? It is decreasing. Right? I have explained you this. Why it decreases? Because the electrons are added to the same shell, as the result of which the net force of attraction between the nucleus and valence electron, what happens? Increases. So what happens? The size decreases. Right? And when we move from top to bottom in the group, the size increases. The size of atom, of element, increases. Okay? So, let's see. Potassium. In our question, there is potassium. So, your potassium belongs to which period? It belongs, first group. Magnesium belongs to second group. Phosphorus belongs to fifth group. Oxygen belongs to sixth group. And fluorine belongs to seventh group. So, these all they belong to the which period they are having? Of all moving from left to right, what is happening? The size is decreasing. Now which is having the least size here? Fluorine, right? Which will have the maximum size here? Potassium. Then would be what? Magnesium. Then would be what? Phosphorus. Then would be oxygen. Then would be fluorine. So the answer of your question would be potassium, the larger size, followed by the magnesium, then phosphorus, then oxygen, and then fluorine. Right? So this is the answer of your question. Now let's take up our next question here. It is, arrange the following elements in the decreasing order of their metallic character. Now you must be knowing what is metallic character. Metallic character is what it is. Chemically it is the electropositivity. Right? Or the tendency to form positive ions. Now what happens to the electropositivity down the group? Say down the group, what is happening? Electropositivity increases. Okay? Now when we move from left to right in the period, what happens to electropositivity? The electropositivity or metallic character decreases, right? Now let's find out to what all periods and groups these elements are. So boron, it belongs to which group? Third group. And second period. Calcium belongs to second group, right? And third period. Sodium belongs to first group and third period. Cesium belongs to first group and seventh period. Magnesium belongs to second group and second period, right? Now, metallic character across the period, what happens? Decreases, because it is proportional to the electropositivity. So which will have the least metallic character in this? The one which belongs to third period. So that is, we will write this boron in the decreasing order, right? So boron. Then which group will come? There is second group and there is second group, right? There is first group also, so it should be most metallic. First group, we have got two elements, sodium and cesium. What happens to the metallic character down the group? It is increasing. So which will be most metallic? The first group and the last element, that is the cesium, would be the most metallic element. Then would be what? Again the first group, that is the sodium. Then what will come? We have got two elements of second group, that is calcium and magnesium, right? Calcium belongs to the third period and magnesium belongs to the second period. So which will be more metallic? The one which is in the third period, that is calcium. Then comes your magnesium. Is it clear? I'll do it again for you. It is boron, calcium, sodium, cesium and magnesium. Boron, calcium, cesium, magnesium and sodium. I'm doing it again for you so that you can understand it properly. Boron, it is third group, second period. Calcium, second group, second period. Cesium, first group, seventh period. Magnesium, second group, second period, right? Sorry, it is second group. Then as sodium, it is first group and second period, right? Now, what happens to the metallic character? It is decreasing across the period. So it is decreasing and it is increasing down the group. So which is the third group element? That is boron. So boron will be least metallic. First group elements will have maximum metallic character, and that to the seventh period, that is down the group. So this will be cesium. Then again first group has sodium. Then second group, there are two elements, that is beryllium is there, magnesium and calcium. So which one is coming below? Calcium. So calcium would be more metallic than magnesium, than boron. This is the way we arrange, okay? But the basic thing which you need to remember is, remember what happens across the period, right? So this is your answer. Now let's take up our next question here, students. It is, arrange the following elements in the increasing order of their valencies. Now what is a valency? Valency is either the group number, or it is 8 minus the group number. Okay. Now magnesium, it belongs to which group? It belongs to second group. So what is the valency here? 2. Lithium, it belongs to first group. So what is the valency here? 1. Carbon, it belongs to fourth group. So what will be the valency here, students? 4. Fluorine, it belongs to seventh group. So what would be the valency? 8 minus 7, or the group number minus 8, right? Actually the valency is given by group number minus 8. So it is 7 minus 8 and we will get what? 1. Right? Then is sulfur. It is the sixth group. What will be the valency? 6 minus 8, that is equal to 2. I told you that we don't take science in case of valencies. Okay? And finally nitrogen, it is belonging to the fifth group. What will be the valency? That is equal to 3. Okay? Now how can we arrange them? So the maximum valency is of carbon. Then comes what? Nitrogen. We have to arrange it in the increasing order. So least valency is of lithium. That is equal to fluorine. Then is 2. Then comes magnesium. That is equal to sulfur. Then comes what? Nitrogen. Then comes carbon. So this is the way we can arrange the elements according to their valencies. I hope this is you are understanding this concept. Let's take the next question here. Arrange the following elements in the increasing order of their chemical reactivities. Now what happens to the chemical reactivity, students? The chemical reactivity of elements first decreases and then increases. Right? So if I am writing the elements of the second period, that is, what are the elements of second period? This is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, right? So what will happen? The chemical reactivity will decrease up to carbon. And after that it is going to what? It is going to increase. Right? Now, what all elements are there? There is sodium, aluminium, phosphorus, chlorine and silicon. The sodium belongs to the first group, aluminium belongs to the third group, phosphorus belongs to the fifth group, chlorine belongs to the seventh group and silicon belongs to the fourth group. Now, what will happen? The maximum reactivity, or it is in the increasing order. So the least reactive would be here silicon. Then would be what? Then would be your phosphorus. Then would be, there is phosphorus, right? It is reactive. Then will come your aluminium. Then comes what? It is increasing, right? So then comes your sodium and the reactivity is equal to the chlorine, right? So the reactivity first decreases and then it increases. Sodium is more reactive than chlorine, so it should be chlorine than sodium, right? So this is the way we can arrange. Now let's take up our next question here. Arrange the following elements in the increasing order of their electropositivity, right? Now let's take up what happens to electropositivity. It increases down the group, right? And along the period it decreases. Okay, now let's see these elements belong to which groups and periods. Cesium, it belongs to first group, 7th period, right? That is your magnesium belongs to second group, and which period? Second period. Aluminium belongs to third group and third period, right? Germanium belongs to fourth group and which period? Fourth period. Chlorine belongs to seventh group and second period. Okay, that is, say if cesium, I'll arrange like lithium, sodium. So which will be most reactive here or most electropositive? The first group elements are electropositive, and that too in the first group. Down the group, what is happening? Electropositivity is increasing. Which is the last element? Cesium. So cesium should be most electropositive, right? Now, this is the second group and the second period. Aluminium is the third group. So what will happen? Whose electropositivity will be more? Electropositivity. If I arrange like this, so magnesium will come first, then aluminium will come, then germanium will come, and then chlorine will come. But here in this case, whose electropositivity would be more? Magnesium, right? After that will be your aluminium. Now in germanium and chlorine, germanium is obviously more electropositive, and chlorine, it is what? It is electronegative, right? So chlorine is right? So it should not have been there. Now what is your answer, students? If such type of questions come, if at all you are getting chlorine here, don't arrange it up. As we are arranging this, please don't arrange it. Do one thing, write chlorine is electronegative. Because students, it is not at all electropositive. How can you arrange it? So write it there that your chlorine is what? Chlorine is electronegative, right? And note this whole thing also. Now let's move to our next question here. Which of the following will have maximum metallic character? Now of these, let's again, for everything student, for solving questions like this, you need to by heart the periodic table. Otherwise you won't be able to solve single question of periodic classification of elements. Got my point? So your gallium, which group, which period? It is the third group. It is the third group, fourth period. Germanium, it is the fourth group and it is carbon, silicon and germanium. This was boron, aluminium, gallium. So it is again what? Second, third, fourth. Fourth period. Arsenic. Where is arsenic? Arsenic is in the fifth group. Right? Where it comes? Nitrogen, phosphorus, arsenic and antimony. Again it is the fourth period. Right? Selenium. It is what? Sixth group. And which period it will belong to? This is oxygen, sulfur, selenium. It is again what? It is the fourth period again. Okay? So this is selenium, fourth period. Then is beryllium. Beryllium is present where? Second group. Second period. Right? So what happens to the metallic character if we move down the group? Down the group, the metallic character increases. Right? So which is present at the bottom? What all? Now if I take gallium, this is in the fourth position, germanium fourth, arsenic fourth, selenium fourth. Right? So these all will be having similar metallic character. Now what we can do? We can't see the group now. What we need to see there is the period. Let's see what happens across the period. Across the period, the metallic character decreases. Right? So say your gallium is belonging to the third group, it will be most metallic. Then germanium is belonging to the gallium is the third group, then germanium is the fourth group, then arsenic, then selenium. Right? And beryllium is of course in the second period, that is beryllium. So which will be most metallic here? This is present in the fourth position along the group. These all, where are they present? They are present in the fourth position along the period. But what you need to see is along the period also. That is, they are present in the fourth position along the group. But you need to see the period also. So which has the most metallic character, student? These all are in the fourth position. Which will be most metallic? Gallium. Got my point? Beryllium is in the second group, but it is in the second period also. So what happens? This will have the least metallic character. Right? So what will be the answer of this question? Gallium. So this is the way we solve these questions. This would be a bit, you must be finding it a bit confusing, but as you start practicing, you will not find it so. Now this is, arrange the following ions in the order of their decreasing sizes. Now in my previous session I told you that cations are smaller than their atoms. Or we can say that cations are smaller than anions. What all are the cations here? The more is the electron lost, the more will be the force of attraction. The more is the electron lost, more is the number of electrons lost for the formation of positive ion. What happens? More is the net force of attraction of nucleus on the electron, right? And less will be the size. So here whose size would be least? Magnesium, because it has lost 2 electrons. Then comes your sodium. So the whole thing, it's vice versa will be true for anions. So less size will be of chlorine and more size will be of oxide ion. Right? Because this oxygen is gaining 2 electrons. So the force of attraction of nucleus on the electrons would be much less as compared to chlorine. Right? So this is all about the questions of periodic classification of elements. Actually, I wanted to tell you the pattern of questions which come from this topic. Now students, you will be able to solve these questions efficiently only if you memorize the periodic table. I hope you will be doing so. Okay? So all the best for your exams, students. And thank you very much for your patience, for listening patiently. You must have gone through all the lectures now of 10th syllabus. I hope you enjoyed the sessions. I hope the concepts are clear to you. And I also advise you to solve as many questions as you can. Thank you once again and all the best for your exams.